In today's tutorial we will have a look at the Baldwin classification. How could we classify ring closing reactions? In the preceding tutorial we looked at some competing reactions. With this starting material, a ketone could be deprotonated by a base, forming this enolate or this other one, which has in addition an stereoisomer with that chain trans to the oxygen. However, as the main products, heterocycles are formed or carbocycles. So let us classify the ring closing reactions by the Baldwin classification. Here a 5-membered ring is formed, therefore we have to write down simply a 5. Then we have a look at the bond which has been broken. So one bond has been formed from the oxygen to that carbon. On the other side, that carbon-bromide bond is simultaneously broken, and this bond is geometrically located outside the ring which is formed. Outside is abbreviated with an exo. Endo would be the opposite. Then the reaction took place at an sp3 hybridized center. This is a so-called tetragonal center, since it has, that carbon has overall 4 substituents, that carbon, that bromide and 2 hydrogens, tetragonal, and this is abbreviated with the expression tet. So, according to Baldwin, this reaction to that tetrahydrofuran derivative is a 5-exo tet ring closure reaction. Here, as a competing product, a carbocycle is formed, also a 5-membered ring. Again, it's the same carbon-bromide bond that is broken, located outside that ring geometrically. So exo tet, the same here. In this case, also 5-membered ring. Again, exo tet. But here a 3-membered ring is formed, and this is therefore classified as a 3-exo tet reaction. Well, let us further have a look at those related examples. We have changed the functionality here a little bit. Here it's simple bromide. There we have an allylic bromide. So electron density is delivered for the 3-membered ring formation. That double bond migrates, eliminating the bromide, and this would be the product. So what happened here? Again, a 3-membered ring is formed. The bond that has been broken initially at the position where the reaction starts here is this double bond. It's located outside that ring. Here is the 3-membered ring formed. There the bond is broken. So again, exo here. But the reaction takes place at an sp2 hybridized center. This is a trigonal center, and therefore we write down the expression trig here. TRIG. G. Then in this case we have changed from a propagule unit, from an allylic unit to a propagulic unit, an sp hybridized center here. Well, if we follow this type of reaction, nucleophilic carbon here attacking in propagulic position, then this triple bond is transformed to a double bond, and then this single bond is transformed to a double bond. The bromide is eliminated. Then we have as a product this allene, and the classification is then again 3-exo, but since it is an alkyne, the carbon has two substituents, that carbon and that, then it's a diagonal center, and therefore we add DIG. It's a 3-exo dig reaction. Thanks for listening.